so here we have number 45?
Yeah.
45.
45. We have a wrecking ball. All right, so the wrecking ball's on the crane. And here it is. And then what happens? All right, the thing snaps and the wrecking ball falls. And so it starts out at height, I don't know, let's say H. We'll just label it that for to start with. And then let's say, here, we'll move this down here. All right, that's not working. Broke up here. All right. So now it's fallen, and it has fallen to a height of h over 2, with this being the ground at 0, right? And we know that this took t equals 1.2 seconds, and we want to know what this t2 is equal to, right? Is that correct? And here's the ground, and that's how long it takes for this thing to go. All right, so how much longer? All right, so we got a bunch of stuff here. We're going to need to use this right here to figure out, we're going to need to use this time to figure out what this is, this distance here. Then what are we going to do with this distance here?
Do not have to be those.
We could. That's an idea. We use that as V naught, right? And then we say, how long does it take to fall the additional h over 2? But we still don't know that distance, do we? Could we use this time to figure out what this distance is? We'll call it delta y. Yes. Using which equation do you imagine? Delta y, acceleration, time. How do we find the distance? Yeah, meat grinder will give us the distance. Then once we got that, we double that, we see how long it takes to fall that distance. That seems to me to be the most straightforward approach to this problem. All right, so part 1. Yes, it is constant acceleration. Part 1, how far did it fall in 1.2 seconds? And we know that's from rest, right? All right. How far did it fall? Okay, this is h over 2, isn't it? Got that? All right. So how far did it fall in 1.2 seconds? As we said, we have v naught is equal to 0. We have acceleration is equal to positive or negative g. We're going to make downward positive or negative. Somebody say something.
Positive.
All right, sure, we'll make it positive. All right. All right, so A is equal to G. Do we know V final? No. Do we know time?
Yeah.
Yes. 1.2 seconds. All right, and what is it we're trying to look for? Try to look for delta Y. We don't know what delta Y is. Okay, we'll give that a higher rank here. Whoops, whoopsie, whoops. All right, here's delta Y. That's what we want to know. So now, what formula we have? We already said. You guys figured this out. Meat grinder. Delta Y is equal to V naught T minus 1/2 AT squared. That's our formula. That's the F of doofus. Now, guess what about algebra?
Is it minus or plus?
Yes, we said it would be plus, didn't we? And then we'll make that a G. Good point, thank you, Dean. All right, so do we need to rearrange anything? No, we don't. Do we have any gifts?
0.
V naught 0. All right, so delta Y is equal to 1/2 GT squared. So this delta Y, or H over 2, right, is going to be equal to 4.9 times 1.44. Calculators. All right, this is 7.056, and we'll be nice and call that 7.1 seconds. I'm sorry, 7.1 meters. Meters. Okay? All right, we did that just putting in the numbers up here. I didn't put them in. I didn't do the substitution. 1/2 9.8 meters per second squared times 1.2 seconds squared. Second squared, cancel second squared, we end up in meters. Okay, cool. All right, so running along. 7.1 meters is our halfway, isn't it? All right, so h over 2 is equal to 7.1 meters. So what's our total h?
14.2.
H is equal to 14.2 meters. Now, is there any way we could start from here and just do the rest of it? We could find out what the velocity must be there and know that it falls an additional 7.1 meters, right? Or we could plug in over here and do the same thing for this 14.2 meters and then find the difference. Tune in later to see how we do it. I like the idea of starting right here with the known distance, all right? With that known distance, we can find delta H because we can now find the velocity. So since we know velocity is equal to v naught plus at, this is for case 1. Started out at 0, the acceleration of g, so v is equal to 9.8 meters per second squared, that's 1.2 seconds. So our v naught for part 2, I'm going to write a weird subscript there, v naught for part 2 is equal to 9.8 times 1.2, and this is equal to 1.17, let's say 1.2, 1.18 meters per second. So that's the initial velocity when it falls that final distance. Of course, probably the best thing to do would just be to put AT in the expression when we do we start case 2, knowing the v naught that we have there. All right, so let's try that. So we know that we have v naught, and that's equal to AT1, which is 1.2 seconds, or we can say g times t1. We know the final, we know the delta y is an additional 7.1 meters, right? Because before it went halfway, so the second half is just going to be another 7.1 meters. We know that acceleration is equal to g. This is all still ticking downward to be positive. And what else do we know? We know we're trying to find the amount of time. All right, so this is for part 2, or case 2, we called it up at the beginning. All right, so now given the things we have here, we have all the stuff we need to use the meat grinder equation, and so we know that delta y is equal to v naught t plus 1/2 gt squared. Again, it's plus because we're taking downward to be positive. All right, so knowing that, since we're going to solve for t, it looks like we're going to have a quadratic expression. We'll say 1/2 gt squared plus v naught t minus delta y is equal to 0. All right, move it along a little bit more. That makes our a term 1/2 g, or 4.9. It makes our b term at, right? That was our v naught, or 9.8 times 1.2. No. Yeah, we'll just use the values. 9.8 times 1.2, and it makes our c term negative delta y, would give us negative 7.1 meters. All right, of course we'll put meters in when we put it into the quadratic formula. All right, so this is our a term, this is our b term, and this is our c term for the quadratic equation. Okay, so we'll put that. And plugging all that in, we get t is equal to 0.499699. I guess we'll make that 0.5 seconds. And that's going to be the one we choose because the other root is equal to negative 2.9 seconds. And of course, we're not going backwards in time. So we'll take this one. The one that is 0.5 seconds. All right. So So I'm also going to solve this another way, but I'll just call that a supplemental version of this same problem.